Hi, hello everyone. Good evening. Welcome to this Unacademy ICSE and ISC YouTube channel. This is Manisha, your class 9 chemistry educator. Completed my graduation and diploma, and I'm a gold medalist in both. I have 6 years of teaching experience. So today what we are going to study? Atomic structure. So this is our fourth lecture of atomic structure and most probably the last lecture. So I would like to tell you about our official Unacademy channel on Telegram. The link of which is given in the description box. You can join this channel for every updates and notifications related to your live class as well as your uh, as well as the notifications for the exams. Okay. Hello Faizan. Good evening. Very good evening. How are you all? Fine. Okay, so do not forget to join this Telegram channel. Okay, and also please do subscribe us on YouTube now if you want to receive the notification of every live class as soon as it goes live. Please do not forget to hit the bell icon. Okay, so please share the classes also with your friends as much as you can, because we want more and more students to join with us on this platform. Okay. Thank you, Fazan, for asking. Yes, I'm fine, perfectly fine. Okay, so please let me know once you please confirm if I am clearly visible and audible. Yes, I am clearly visible and audible so that we can start our class. Yes, okay. So tell me first. Okay, hello Avinash. Good evening. Very good evening. Okay, so we are not going to start J.J. Thomson's atomic model. Very sorry for the typing mistake. It should be your Rutherford atomic model. Okay, so J.J. Thomson's atomic model we covered in our last class. Today we will start Rutherford's atomic model. Okay, okay. So, all ready? Everyone tell me please, all ready? Okay, okay Faizan, chalo, very good. Avinash, ready? Yes. So let's have a quick recap what we learned in our previous class so that we can continue from that. Okay. So now we read about the properties of proton. So that it has charge equal to 1.6 into 10 to the power minus 19 coulomb and mass is 1.67 into 10 to the power minus 24 gram. Yes, Avinash, ready, set, go. Okay. And also proton will stay in your nucleus along with the neutrons. Then we studied about John Dalton's atomic theory, which suggested that your atoms are indivisible, but it was discarded as your more fundamental particles were discovered. Yes, these are the chronological order of the atomic models. And in some books, I would like to clear this concept that in some books you will find that this model is named as planetary model. Okay, this model is named as planetary model, and this model is named as nuclear model. Okay, so there is a confusion in both the models, but in your book it is given as planetary model. So we will go with this only. Okay, and this is the entire chronological order by that is which model was given by whom. We have covered your John J.J. Thomson's model of an atom, that is your plum pudding model, where your the edible part is your positively charged means positive charge which is spread all over the sphere, and your dry fruits or the seeds in the inside the watermelon is your electrons which are embedded on the positive charge. So all these things we have already covered. Okay, and the main achievement of Thomson's model was that he was able to explain why there is the electrical neutrality existing in your atoms. Okay, why your atom is electrically neutral as a whole. So he was able to explain that. Yes, and demerit, he could not explain, the model could not explain the findings of Rutherford experiment, and hence it was discarded. Again we studied about that. Hello Chetna, welcome to the class. Okay. So again we studied that how Rutherford designed this gold foil experiment. he used alpha particles to hit the gold foil, and the results that he found was very much astonishing, because he found that certain particles were getting deflected by certain angles, some were crossing undeflected, and 1 out of every 12,000 or 10,000 particles was rebounding to its original path. Okay, so this was a very surprising finding, because it was not matching with the Thomson's model. Okay, so these findings we have already discussed. So now we will the conclusions that we will study now, that based upon the observations, based upon the conclusions, what did Rutherford say about his atomic model, what were his findings. Okay, so anybody is having any doubt in the previous class, tell me fast. Anybody is having any doubt from the previous class? Yes, clear, tell me. Chetna, Avinash, Faizan, only 3 of you I can see, so please let me know if you have any doubt. Yes? Okay, Faizan. Okay, Avinash. Very good. Okay, now let's start. So, okay, Faizan. Okay, very good. Okay. Now, Rutherford's atomic model. This was known as your nuclear model, or you can say planetary model. Okay, in your book, it is compared with the solar system. So, we will call it planetary model. Okay. Thank you, Avinash. Thank you so much. Okay, thank you. So, Rutherford's model is known as planetary model. In some books, you will find it like written as nuclear model. So, we are not means concerned with what was the name of the model. We are concerned with the findings that he gave us in the form of model. Okay, clear? So, in nuclear atom, the protons and neutrons, they were comprising, means they were responsible for the entire mass of an atom. That we know, that your entire mass of the atom is depending entirely on your neutrons and protons, which is located in the nucleus, that is at the center of the atom. Okay, and the electrons, they are distributed how? They are distributed around the nucleus. Okay. मैम मैं सीबीएसई बोर्ड से हूँ so Faizan, nothing is there in your CBSE board. Also, you have structure of atom in your class 9. No, you have this structure of atom. Yes, sure, Faizan. It is nothing to worry, bacha. See, your CBSE and ICSE board almost have the same portion. Okay, so yes, of course you can study, because everything here that is covered will also belong to your CBSE board, because you again have structure of atom in your CBSE board. Yes, chapter 4 I suppose is your structure of atom in chemistry. Yes, so yes, it is important for you too. Okay. Okay, Faizan, Avinash, Chetna, everyone. So, back to the topic. Yes, tell me fast. Okay, Faizan. Okay. No issues. Okay. So, if you have any problem anywhere, let me know. Education doesn't see age and board. Yes, Avinash correctly said. Yes. Okay. Okay, let's come back to the topic. So, what we see, that your protons and neutrons, they are located in the nucleus, that is at the center of the atom. And how these electrons are distributed? They are distributed all around the nucleus. Okay, they are distributed all around the nucleus, and they occupy your most volume of the atom. Okay, they will occupy only the most volume of the atom. Now, you can see, you can understand from this comparison that it is given in this written format, that nucleus is very small. Nucleus is very small, बहुत छोटा है. It is very small than the rest of the atom. Okay, so if you can imagine, so now let's imagine atom to be a professional football stadium. If your atom is a professional football stadium, nucleus will be about a size of marble that is kept in the middle of the stadium. Just imagine that according to the size of atom, nucleus is very small. Okay, clear everyone? Is it clear? Faizan, Avinash, Chetna, clear? Okay, that means the size of nucleus is very small, but still you can think the mass of the atom is determined by number of protons plus number of neutrons. Yes, That is, the mass of atom is determined by the protons and neutrons. Okay, so this is your nuclear model, or you can say planetary model, okay, of Rutherford, okay, of Rutherford. So, okay, clear, very good. So we will now, okay, before going to the explanation of the Rutherford's model, atomic model, let me tell you, just quickly let me tell you about the subscription features of Unacademy. So you can learn live from the comfort of your home. You can have unlimited access to all the courses. Top educators are there to teach you live on this platform. Okay, and you are having regular doubt solving sessions. Exhaustive coverage of syllabus is there. You will receive mentor and guidance. Study materials are there. Practice tests, live tests. It is so many features are there. Okay, so all of these features will be available at single platform with single subscription. And if you take the subscription for class 9, you will receive subscription for 10, 11 and 12 just for free. Means you don't have to do anything. Okay, you don't have to do anything. You will receive this just for free only with single subscription. Again, India's top educators are taking your class. Like I will be there for chemistry, Vani ma'am will be there for biology, Kalyan sir there will be for physics. Okay, so and again if you want to attend the classes in Hindi, you have Param batch where again your India's top educators are there. Again we have started a new batch called Udan batch, that is from 17th of January. So you can see with single subscriptions you can have access to almost all the courses and batches that is ongoing on the platform. Yes, clear? And if you want to take the Unacademy Plus subscription, it is again available at very affordable prices, like 3 months. For 3 months, it's starting from 3 months and till 48 months. Ma'am, this is only for ICSE. Yeah, no. This feature is for every board. Okay, be it CBSE, ICSE, any other board. Okay. So if you take the subscription for class 9, you will take subscription for 10, 11 and 12. Yes, free. Avinash, you don't have to pay anything for 10, 11 and 12. That will be for free. Let's suppose you take subscription for 1 year. So for 1 year, your class 9, 10, 11, 12. These 4 classes will be free. You can access to all the courses, all the study material, everything. Okay. So if you are really willing to take the subscription, do not forget to use my code Manisha Live because this will fetch you 10% discount. Read both chats together, ma'am. Which chat you are asking, Avinash? Ma'am, this is only for ICSE 10, 11, 12 free. Yes, 10, 11, 12 free will be there, Avinash, and it is only for ICSE. Yes, if you take the subscription for ICSE category, you will be given only subscription access to ICSE category, I suppose. For this, you need to talk to the Unacademy person that if you will get the subscription for ICSE, you can get the subscription for CBSE or not. Okay. So I suppose this is not there, but because if you subscribe for ICSE category, you will only have access of ICSE categories classes. Okay. Okay, Avinash. Okay. So do not forget to use my code Manisha Live. So this is my code, and also we are having an offer till 31st of January that if you take the subscription before 31st of January, you will get 3 months extra subscription for 1 month and more. Faizan is telling, ma'am, please take daily class. Okay, Faizan, but this is not possible, bacha. I will try to take the daily classes from February, but now we will have 1 day class for class 9 and 1 day class for class 10. Okay, so there has to be a gap because that's why means there is a gap. Means 1 day I take for class 9 and 1 day I take for class 10. Okay. So I will try to cover your syllabus in this period only. So do not worry about your syllabus. Okay. Okay. So let's start now. Let's come back to our topic. Everyone pay attention. Okay. So everyone pay attention to the class. Now everyone ready to start the topic? So we will discuss the main feature of the Rutherford's model. Okay, we are going to discuss main features of, okay Avinash, main features of Rutherford model. Okay, what are the main features of Rutherford model now? Okay, very good Fazan, very good Avinash. So main feature is that first, according to this model, the atom is containing a very large empty space. Okay, the atom is containing a very large empty space, and it is also containing a very small part called nucleus, which is situated at the center of the atom and which carries almost entire mass of the atom. Okay, so first thing that is written about your Rutherford model is that the atom contains what? It contains nucleus. And what is there in the nucleus? Nucleus is situated in the center of the atom. Okay, center of the atom. And in this nucleus only the entire mass of the atom is existing. Okay, this nucleus only carries the entire mass of the atom. Clear everyone? So your atom contains a nucleus that is very small in size, which is situated at the center of the atom, and it carries the entire mass of the atom. Clear? Okay? Okay. Next is that the electrons, these are distributed in the empty space of the atom around the nucleus. Okay, these are distributed in the empty space of the atom around the nucleus, which are rotating, or you can say which are revolving around the nucleus in closed circular path. Okay, very good. So the electrons, these electrons are distributed, or you can say these are kept. Okay, any word you can use, distributed in the empty part of the atom. Okay, empty part of the atom, and these revolve. Okay, these revolve around the nucleus. They are revolving around the nucleus in closed circular path. Okay, they are revolving around the nucleus in closed circular path, and what these paths are known as? These are known as your orbits. Okay, understood everyone? So electrons are distributed in the empty part of the atom and around the nucleus, and they revolve around the nucleus in closed circular path called orbits, or you can say different concentric paths called orbits, like this. This is your nucleus and different concentric paths are there. In these paths only your electrons are revolving around the nucleus. These are termed as orbits. Is it clear everyone? Okay, very good. So this is your orbit. Okay, understood? Avinash, okay, very good. Faizan, Chetna, if you're there in the class, please let me know if it is clear to you. Yes, third. Let's now talk about the third feature, that is your number of electrons in the orbit is equals to number of protons in the nucleus. Okay, this was also told by your Rutherford. Number of electrons in the orbit. Okay, very good Faizan. Number of electrons in the orbit is equals to number of positive charge, or you can say protons in the nucleus. Because at that time your neutrons was not known, so Rutherford had not discussed about your neutrons. Clear? Yes. So that's why your atom as a whole is electrically neutral. So Rutherford gave this explanation. He also gave this explanation that since the number of electron is equals to number of proton, so your atom as a whole is neutral. Okay, as a whole is electrically neutral. Yes, clear? Now fourth observation, that volume of nucleus is very small as compared to the volume of the entire atom. As I told you just now that if you take your atom to be a size of football ground, football stadium, your nucleus will be of the size of the marble that is kept in that stadium. So you can imagine that the volume of nucleus is very smaller than your volume of atom. So volume of nucleus is very small than volume of atom. Clear? Is it clear everyone? Yes. Fifth observation is that most of the space in the atom is empty. How did he come to this conclusion that most of the space in atom is empty? Because many alpha particles, many rays were passing undeflected. They were passing undeflected through the gold foil. That's why he considered that most of the space is empty inside the atom. Okay, inside the atom. Clear? So because of that only the alpha particles were passing through the gold foil undeflected. Okay. So what were his observations? First of all, this atom contains a very large empty space. Because of that only alpha particles were passing through the gold foil without deviating from the path. Okay. So, fourth is that volume of nucleus is very small than the volume of atom. That's why your 1 out of 12,000 particles were getting rebounded. Yes, that was the rebounding was very less. So that's why. So this was proved when your most of the alpha particles were passing straight through the gold foil and very few were getting deflected and 1 out of 12,000 was rebounding to its original path. Okay. Ma'am, marble is referred to as spherical objects of glass available in 1 rupees. Yes, Pankaj. Marble is that only. Yes, we play games with the marbles and all. Hello, Avinav. Welcome to the class. Yes, okay. Okay, now then he could explain the electrical neutrality of the atom, that is total number of electrons in the orbit is equals to total number of protons in the nucleus. Okay, then what were else his findings? That the electrons were revolving around the nucleus at large distances from each other and they were revolving around the nucleus in closed circular paths known as orbits. Okay, these were known as orbits. Okay. Okay. Now atom contains the nucleus at the center. Okay, there is a positively charged mass at the center of the atom. Okay, that is known as nucleus. So atom is containing nucleus at the center and this is responsible for carrying the entire mass of the atom. Means entire mass of the atom was concentrated in the nucleus itself. You can imagine the volume of atom is so big than your volume of nucleus, but still your entire mass of the atom was concentrated in the nucleus. Okay. So therefore your nucleus was the densest. Okay. It was the densest part of the atom. Okay. Where your maximum mass was concentrated. That's why when your alpha particles were means getting hit to this nucleus, when they were hitting the nucleus, they were getting deflected. Okay, by certain angles and they were also getting rebounded because alpha particles were also positively charged. Nucleus also contains positive charges. So that's why they were getting repelled. They were getting deflected. Clear everyone? So this deflection of alpha particles proved that your nucleus contains protons. Okay, the deflection of alpha particles proved that there is a presence of positive charge inside the nucleus. I suppose it is clear everyone. Let's just let me know in the comment section. Avinash, Avinav, Faizan, Chetna, please let me know. Is it clear? Okay, Avinav, very good. Avinash, Faizan, Chetna, please let me know. Okay. Ma'am, my physics teacher tell nucleus of an atom is imaginary. Yes, ma'am, clear. Ma'am, since electron has negligible mass, so do protons have attractive force enough to attract 2-3 electrons? See, Avinash, attraction, the force of attraction is not dependent, means like in case of mass, okay, in this case, your electron and proton, because the masses are very negligible. The like gravitational force of attraction, that is depending on mass. But here the electrostatic force of attraction depends on the charge, not on the mass, okay. So the charge of electron is equal to charge of proton. So one proton will be able to attract only one electron. Clear? The electrostatic force, if you see the it means formula of electrostatic force of attraction, that is coming out to be K Q1 Q2 by R squared. So you can see Q1 is the charge, Q2 is the charge. So electrostatic force of attraction depends on the charges of the electrons and protons and not on the masses. Okay, it is not like gravitational force that is depending on the mass. Clear, Avinash? Faizan, yeah, nucleus is not imaginary, bacha. Nucleus is there, okay, and it is containing your protons and neutrons in a consolidated manner. That is your concentrated manner at one place, okay. That is your nucleus. Yes, but the orbits are imaginary. He or she must have told you that orbits are imaginary. There is nothing such as orbits existing inside the atom, okay. Orbits are imaginary. Clear, everyone? Is it clear? Okay. Tell me fast. Avinash, Faizan. Okay. Abhinav. Okay. Ma'am, how can nucleus be imaginary? It proves Rutherford wrong about deflection of alpha particles. Yes, Avinash, you are correct. The entire Goldfold experiment will have no means proof if the existence of nucleus is imaginary. Okay. Okay. So existence of orbits are imaginary. There is nothing such as orbits. Okay. Means nothing like closed ring type structure is there. No circular paths are there. So these orbits are imaginary, but this nucleus is real. Okay, nucleus is real. Orbits, orbitals, subshells, all these are there. But again, this is all means imagination. Okay, electrons are like found in the form of clouds. This is the existing model that we are learning about. Let me show you. You will read about this model when you will go in class 11. This is the model of quantum mechanical model. There is nothing such as your orbits. Okay. Clear, everyone? Okay. Okay, so should we start with defects in Rutherford's model? Why this Rutherford model was discarded? Yes? Okay, very good. So now positive, okay, so these all things is again here. Now drawbacks of Rutherford atomic model. We will discuss about the drawbacks. Okay. Now first drawback is that Rutherford did not specify the number of electrons in each orbit. Means each orbit will contain how many numbers of electrons, this Rutherford has not determined. Okay. So number of electrons were not specified, number of electrons in orbits. Okay. In each orbit was not specified by Rutherford. He did not tell us how many electrons will be accommodated in one single orbit. Yes, everyone understood? Tell me fast. Avinash, Abhinav. Yes? Okay. If it is clear, I am proceeding to our next drawback. Avinash, Abhinav, Faizan. Okay, very good, Chetna, if you are there in the class. Okay. Now, according to this one electromagnetic theory, if a charged particle, okay, according to a electromagnetic theory, if a charged particle like electron is accelerated, charged particle is there. If it is accelerated around another charged particle, that is your proton, then there will be continuous loss of energy. Why? Due to continuous emission of radiations. Okay. So if any charged particle is accelerated in a very high speed around a charged particle only, that charged particle, that revolving charged particle will continuously loss energy due to the emission of radiation. Okay. Now, Rutherford told that the electrons are revolving around the protons in the orbits. Yes, he told that. So this loss of energy will be there in electrons only, and one time will come like when this electron is revolving, is it rotating, and the loss of energy will be there, and one time will come when it will fall in the nucleus and the atom will collapse. Yes, and the atom will collapse, because according to the electromagnetic theory, you can say, or according to the mechanics and electrodynamics, there is a rule that if electrically charged particle is in a continuous motion around another electrically charged particle, it will continue to radiate energy. That will be the loss of its energy, and as a result, electron will lose all of its energy, and eventually it will fall into the nucleus, and hence your atom should collapse. Okay, hence your atom should collapse. But this is not happening, no. If this would have happened, then we will not be able to exist. Yes, if there will be no atoms, if the atoms would have collapsed, then we would have not existed, because everything in this universe is made up of atoms. Yes or no? Tell me fast. Yes, Avinash, Abhinav and Faizan, clear? So this collapsing, okay, the such a collapse does not occur. Yes, eventually the electrons are not falling into the nucleus. Such a collapse is not occurring. Okay, so this Rutherford model, okay, this Rutherford model could not explain this theory. Okay, could not explain that why electrons are not losing their energy when they are continuously revolving around the protons. Okay. Ma'am, just out of curiosity, where is quantum model of atoms useful? See, Abhinav, your quantum mechanical models are useful to know the electronic configuration, your arrangement of electrons, okay? Then to know the speed and charge of the electrons, okay? Again, to understand the subatomic arrangement inside the atoms, okay? So all these things, your quantum mechanical models are necessary. If you want to know about the hybridization, why the shape of methane is tetrahedral, why phosphorus form PCl5 compound while the phosphorus is having its valency as 3 only, how 5 chlorine atoms can get attached to it, why some structures have this triangular pyramidal shape. So all these things are explained due to your quantum mechanical model only. Okay. Clear, Abhinav? So everything in this universe, why it is happening, why such compounds are formed, what is the arrangement of electrons, why electrons are first filled in your 3D means 4s subshell, then 3D subshell. Okay, because logically 3D comes before 4s, but electrons gets filled in 4s first, then 3D. Why do transition metals show such a multiple number of oxidation states? All these things are known to us due to quantum mechanical model of atom only. Okay. So for learning atomic structure, why don't we use quantum atomic model instead? Abhinav, see, the quantum mechanic model is so complex that to understand that you need to understand the basic things, means how that developed, okay, how that orbitals, the concept of orbitals came into being, what is this principal quantum number, azimuthal quantum number, what is the importance of this. All these things you will understand only, you will only once you are means aware of the history of the development of atomic model, like what are the orbits, how the scientists develop means the explanation for these orbits, why electrons are revolving, why electrons are living in the orbits, what is the energy possessed by the electron in the first orbit, how do we means take out the angular momentum of the electron, because if they are rotating somewhere, so they will have some angular momentum. So if that angular momentum is quantized, what are quanta, and all these things we need to understand, okay. That's why we need to study from the beginning, then only we can learn your quantum mechanical model, okay. Yes, Avinash, we need that level of concept, because without understanding the letters, you can't form the sentences. Okay, so you need to have the knowledge of letter first, then you can form words, and then finally you can form sentence. So that's why we need to understand each and every atomic model, so that we can understand what is the importance of this Schrodinger model of atom. Okay, clear everyone? Okay. So, Avinash, ma'am, you explained azimuthal quantum number in special class or plus class, right? Abhinav, I explained the azimuthal quantum number in both the classes, plus and special, both the classes. In while I was explaining you the Bohr-Bury form of periodic table, long form of periodic table. Okay? So, Rutherford model could not explain the theory of collapsing of atom. Okay, very good, Abhinav. So this collapsing means why the atoms are stable. Okay, this Rutherford's model could not explain. So this according to this theory, the atoms would have been very much unstable and they would have collapsed. They would have ceased to exist. Okay, but this is not the case, because matter would not have existed if atoms were not existing. Okay, so we can see matter, that means atoms are there. So Rutherford model could not explain the structural stability of atom. Okay, this could not explain the structural stability of atom. Yes, Faizan, I am teaching you. Okay. Yes, you are in 10th or what? Okay. Ma'am, please come in our topic. Yes, Faizan, I have come in your topic. So, these were the two drawbacks of Rutherford's model. First, he could not specify the number of electrons found in each orbit. Also, he could not explain the structural stability of atom. Okay, why this atom is so stable, why the matters are existing, all these things he could not explain. Clear? Is it clear? Yes? He couldn't reason his hypothesis. Yes, Abhinav, he couldn't reason his hypothesis that he gave as in the form of atomic model. Okay? Okay. And also he could not explain that why there is not a continuous loss of energy in atom. Okay, why there is not a continuous loss of energy in the atom, this also he could not explain. Okay, because if electron suppose loses energy continuously, okay, then electron would lose energy in the form of radiations. Yes or no, tell me first. If electron will have to lose its energy and it is a charged particle moving at a very high speed, then it should lose energy in the form of radiation. Yes, and that radiation will be like we can see the definite lines of frequency coming out of electron if it would have been losing energy continuously, but that is not the case. Yes, electron is not losing its energy continuously. So why it is not losing? Means being a charged particle, also revolving around a charged particle in such a high speed, why it is not losing its energy, that also your Rutherford could not explain. Okay. Okay. So Clear? Sorry, ma'am, we go out of topic too much. It's okay, Avinash. It's okay because I know at your age, students generally have a lot of curiosity. I too had when I was your age. Okay, so it's not nothing a great deal. It's okay if you ask your curiosities, if you ask your queries. It's okay. Okay, everyone understood the defects in Rutherford's model. Avinash, Avinav, Faizan, Chetna, everyone understood? No doubts? Okay. So to overcome, okay, as Rutherford model was discarded, now came the Neil Bohr. Okay. Now came our Neil Bohr in 1913. He was a Danish physicist who gave who gave the explanation for the stability of an atom, that why atom is so stable in nature, okay, but in a different manner. Clear? Okay, very good. So after your Rutherford's model was discarded, we study about Bohr's model of atom, or you can say Bohr's atomic model. Okay, Bohr's atomic model. And he gave his model in 1913 where he explained the causes for the stability of the atom. Okay. Now, we will start the postulations of Bohr's atomic model. Okay. We will start the main postulates of Bohr's atomic model. SPDF block elements. Okay, Avinav, very good. You are remember. Okay. So first postulate, okay, postulate, why we are telling it postulate? Because he did not conduct any experiment, he gave the postulates, okay. So main postulates were that, okay, so Bohr basically, he was the first, okay, he was the first one to propose a quantum mechanical model of the atom. So Bohr was the first to propose a quantum mechanical model of the atom. Okay, quantum mechanical model of the atom. Clear? To whatever the objections were raised to your Rutherford's model and to explain the everything, your spectrum of electromagnetic radiation and all, he proposed a quantum mechanical model of the atom where he told that your angular momentum of any electron is quantized. Okay. So let's study about the main postulates of your Bohr's atomic model. So first of all, the main postulates were that atom has a nucleus where all the present means atom has a nucleus where all your positive charge is present at the center of the nucleus. That is also there. A fundamental particle in the nucleus of an atom which carries mass of yes Faizan and have no charge is neutron. Yes, but neutron was not known at that time, no? Faizan, neutron was not known at that time. Okay. So first postulate, let us study our first postulate. Ma'am, what I remember, Schrödinger proposed quantum mechanical model, but yes, Neil Bohr was he was the first to propose a quantum mechanical model, but his model was not so successful. So Schrödinger gave an equation. Okay, he gave a mathematical equation, that is the sign of chi, where he introduced this NLM, that is your principal azimuthal and magnetic quantum number, due to which we call it quantum mechanical model, or you can say Schrödinger model of atom. Okay, but Neil Bohr was the first who at least started the gave the postulates which was based on your quantum mechanical model of the atom. Clear? Because the idea of orbits, subshells, that was given by your Bohr's atomic model. Okay. Schrödinger gave this equation that is known as wave function and known as Schrödinger equation. Okay, this is your chi. Electron density. To find the electron density, where will you find the electron density inside the atom? This is the address of electron. Okay. Understood, everyone? Okay, very good, Avinash. Very good, Abhinav Faizan. Okay. So first postulate was that electron that are revolving around the nucleus are confined to certain fixed orbits, okay, that were known as shells. Okay, so electrons were revolving around the nucleus are leaving, or you can say confined. Okay, they were confined, they were not allowed to change their orbits or shells, okay, to certain fixed orbits that were known as shells. Okay, that were known as shells, or okay, understood everyone? 2n square, yes, that were known as shells, or you can say energy levels. Okay, energy levels, and each of the shell has fixed energy level. Okay, and each orbit has fixed energy level. Each orbit has fixed energy level, and every electron residing in the particular orbit requires to have that much energy to live in that orbit, to revolve in that orbit. Okay, so each orbit has fixed energy level. Yes, very good, Faizan. Clear, everyone? Second postulate was that while your electron was revolving, okay, while electron is revolving around the nucleus, it does not loses or gain energy. Okay, it does not lose or gain energy. Clear? Is it clear, everyone? So when electron is revolving around the nucleus, it is not gaining energy, neither it is losing energy. Okay, understood? Now third observation or third postulate, that any electron, if it is revolving in a particular orbit, so if it gains, let's say if it gains a certain amount of energy, so it can jump to its higher energy level, that is higher orbit which is having higher energy level. Okay, so if any electron, an electron gains energy, okay, it can jump to higher orbit level. It can jump to higher energy level, or you can say higher orbits, because orbits are only the energy level according to Bohr. Okay, higher orbits, and if they loses, okay, if they lose energy, they will jump to lower energy level. Okay, they jump to lower energy level or orbit. Clear? Is it clear? Because every orbit has fixed amount of energy. If that electron has energy more than the energy of orbit, or less than the energy of orbit, it cannot stay in that particular orbit. Okay, so accordingly it will jump according to its convenience. If it is having more energy, it will go to higher energy level. Less energy will come to lower energy level. Okay, understood? Okay, and for convenience, okay, for simplicity, to understand the model simply, okay, so for simplicity, these energy levels, these orbits, okay, these orbits were termed as energy levels by Neil Bohr. So these energy levels were labeled as K, L, M, N, like this. Okay, or you can say first energy level, second energy level, third energy level, that we are writing n is equals to 1, 2, 3, 4. This n is what? Number of orbits or energy levels. Yes, Faizan. K is equals to 2, no. K is equals to 1. K is the first orbit. L is equals to 2. M is equals to 3. N is equals to 4. Okay. Okay, you are telling the number of electrons. Okay. But Faizan, if you are telling the number of electrons also, in case shell, okay, it's okay that 2 electrons will be there. But in L, it will be 8 electrons, no, according to the formula 2n square. L will have 8 electrons and not 18 electrons. Clear? M will have 32, not 18. Faizan, what you are doing? You are all calculating the wrong. Number of electrons is wrong that you are writing. Okay? So here in L subshell it will have 8 electrons, no, according to this formula 2n square, and M will have 18 electrons, N will have 32 electrons. Okay, clear everyone? Tell me fast. Okay, and how these shells were numbered? These shells were numbered from inside to outside. Okay, like the shell which was closer to nucleus, they were numbered as K. That means first shell. The after that L. After that M. Means the shells were numbered from inside to outside. Okay, clear everyone? Okay, understood? Okay, one more thing that you should understand is that by the time, okay, by the time the electron remains in any one, let's say if an electron is designated K shell, okay, if an electron is designated K shell, electron is designated K shell, means it is living in K shell. So by the time it is living in its K shell, that is any of its one single shell, okay, the electron remains in any one of the allowed stationary orbits, it does not lose energy. That you have understood. It does not lose energy. Yes, it does not lose energy. But the outermost energy shell in an atom cannot have more than 8 electrons. See, Faizan, that is a different thing. Okay, the thing that you are talking about, that is a different thing. That you are talking about orbitals. Okay, outermost energy shell, yes, you are telling correct that it cannot have 8 electrons, but that is a different thing. So to understand this, you have to understand your concept of orbitals and subshells that is there present inside the orbit. Okay, that you need to understand. Okay, that octet thing is different thing. Clear, Faizan? Okay. Is it clear, Faizan? Because see, if we are telling like, let's say, which example should we take? Let's take potassium example. Okay. So potassium's atomic number is 19. So it will have electrons like 2, 8, 8, 1. It is the electronic configuration. So as per the rule, it should have been like this. K is equals to 2, L is equals to 8, M is equals to 18. Like this it should have been the rule. But this is not the case. We are having the electrons arranged in this manner. This is because of the presence of subshell and orbitals. Okay, because of subshell and orbitals. Understood? This is a very much different thing. This will be like this. 1s2, 2s2, 2p6, 3s2, 3p6 and 4s1 like this. Okay, now you have to understand what is this s, what is this p, why we are writing 2 before that. Okay, so these are all these orbital subshell level. Okay, so for this we need to understand every quantum number and the formula that is followed here. Okay, is it clear, Faizan? Okay, so we will understand that also. Do not worry. But now we have to understand first Bohr's atomic model. Then we will understand this when we will come to your Schrodinger atomic model. But we will not study this in your 9th standard. This you will study in your 11th standard. Okay? Okay. P can have maximum 6. Yes, Abhinav. P can have maximum 6. S can have maximum 2. D can have maximum 10. Yes, very good. Okay, and in cesium it is 2, 8, 18, 8, 1. Yes, Avinash. Good. So it is lithium, sodium, potassium, rubidium, cesium, francium. Okay. F can have maximum 14. Yes, Avinash, then it is again the case of your Aufbau principle. Okay. Aufbau principle, according to that only electrons are filled inside the energy shells. Okay. Yes, F can have maximum 14. Very good. So all of you know many things about this quantum number. Very good. Okay. Clear everyone? Okay. So you have to understand now again Aufbau principle to understand the distribution of electrons in the shells, subshells and orbitals. Okay. Aufbau principle you have to understand. Ma'am, you only told in plus class. Okay, Abhinav, maybe I would have told. I do not remember that much. Maybe. Okay. So I was talking about that when your electron is remaining in any one of the allowed stationary orbit, in whichever orbit it is allowed to stay. Okay, it does not lose energy. Okay, and this state, okay, this state, such a state is known as the ground or normal state of electron. Such a state is known as ground state. Okay, such a state is known as ground state or normal state. Clear? We all know all chemistry about chemistry. Very good, Avinash. Okay. So if I say ki this hydrogen atom, inside hydrogen atom, electron is in its first shell. That means this is the ground state of this electron. That means it is not losing any energy. It is having its in its ground state. Clear? And if we provide some energy to this electron and let's say it jumps to its higher energy level, then we say that it is in its excited state. Clear? Is it clear? Okay. And one more postulate for Bohr's atomic model. This was your fifth postulate is that, which is not given in your book. I would like to discuss yet that whenever your electron loses energy or gains energy, okay, whenever your electron loses energy or gains energy, so what happens? It either jumps to its higher energy level or either jumps to the lower energy level. Okay, so whenever it is jumping from one stationary orbit to the another, there is a emission and absorption of energy in the form of radiation. Okay, in the form of radiation. So electrons can absorb energy in the form of radiation. Absorb or gain, you can say. Sorry, absorb or loses. You can write absorb or loses. Absorb or loses energy in the form of radiation when it jumps from one stationary orbit to the other. One stationary orbit to other. So whenever it is jumping, like if it is like say it is first energy level, it is second energy level. One electron is in the second energy level. Somehow it loses energy and it wants to jump to first energy level. So it will lose the energy in the form of radiation. Okay, this is the radiation. Clear? And now the electron will jump to first level. Is it clear, everyone? Tell me fast. Yes? And whenever the electrons, okay, whenever the electrons moves from inner orbit to the outer orbit by absorbing energy, then we said that electron is in its excited state. That I told you. The electrons are in the excited state. Clear, everyone? Okay. And sixth one is that sixth postulate of Bohr's atomic model is that the force of attraction towards nucleus. Why it is like that? That electrons are not means like attracted towards the nucleus and why they do not fall in the nucleus. Okay. So the force of attraction of the nucleus is equalized or you can say balanced by the centrifugal force of the moving electron. Okay. So force of attraction is balanced by the centrifugal force of the moving electron. Okay, centrifugal force of moving electron. Clear, everyone? Hello Bhumi, welcome to the class. Yes, Avinash, we can surely have some questions in our YouTube sessions also. Sure, we will have, but today it is time now. Okay, so we will not have the means polls or questions now, but yes, certainly we can have some questions in our next session. Okay. So all these are the 6 important postulates of Niels Bohr's atomic model. In your book, only 3 postulates are given. I have given 3 extra postulates. Please go through these postulates and let me know if you have any doubt in these postulates. So Bhumi, Avinash, Abhinav, Faizan, Chetna, everyone in the class, Bacha, please let me know. Was this session helpful? Did you understand everything? Yes? Everyone, please let me know if it is clear to everyone. Okay? Ma'am, okay. Okay, Bhumi. Okay, Bhumi. It's okay. You can watch the recorded session after I will finish the class. You can watch the recorded session. Okay? Okay. So this was all for today's session and I hope you liked it. And please do not forget to like the class if you really liking it, and do not forget to share the class with your friends. Do subscribe the channel also, and if you want to join with me on our Unacademy app, okay, so that also you can join. And we are again having classes for class 9 from 5:15 p.m. okay, 5:15 p.m. So again you are having so many features of Unacademy, free special classes. Okay. Okay, so why you are writing like that, Avinash? You will also teach or what? Fizan, thank you, ma'am. Okay, Fizan, thank you so much, everyone. Okay. So Unacademy free classes will give you real-time interaction with your teacher. Also, you can participate in live quiz through polls. You can have your leaderboards. You can ask questions using the question tab. Okay. So everything you can have with free classes. These classes are absolutely free. You don't have to pay anything for these classes. Again, Unacademy Learner app you have to install. You click on Get Started, click on Mobile Number, enter your phone number, and you will receive an OTP. Create your account. Then after that, select the goal, that is your ICSE. Then select your class, language, okay, and you can use my code Manisha Live to unlock all the class for free. Ma'am, I was asking Fezan. Yes, I understood, Avinash, that you are asking Fezan. Okay. I got it. Okay. Okay, about salary. Okay. Okay, it's okay. चलो कोई बात नहीं. So we will again have our session on Monday at 8 p.m. on YouTube. Okay. We will have our next session on Monday at 8 p.m. on YouTube. So please do everyone join the classes on Monday. Okay. And if you want to join me on the Unacademy app also, there also you can join in the special classes. Okay everyone. Okay. Okay, thank you everyone for having such a nice session, for watching this class live. Yes, so bye everyone. Take care and good night.